Hello viewers, question 2, and we have another trio of forces to find the resultant of. We have a 12 Newton force acting 45 degrees above the horizontal on the right. We have an 11 Newton force acting 25 degrees below the horizontal on the right. And we have a 10 Newton force acting exactly to the left. We want to find the resultant of those three forces, so they are equivalent in combination to which one force. That's what we need to find. Let's draw our force table. So we've got a horizontal column and a column for the vertical component of the forces. Let's begin with the 10 Newton force because this is the easiest since it's exactly horizontal. So our horizontal component is 10, but it's pointing to the left, which makes it negative. And we have a vertical component of 0 because it is horizontal. We also have a 12 Newton force 45 degrees above the horizontal. So we need to work in terms of a right triangle. If we have a force acting at an angle, we're always trying to get a right triangle out of the situation. Since our angle is with respect to the horizontal, that makes the horizontal component the adjacent side. And we know the hypotenuse is 12. Adjacent and hypotenuse, that means we're dealing with cosine of 45 degrees. And the hypotenuse is 12. Since that's pointing to the right, that's positive. And for the vertical component, we're dealing with the opposite side of our triangle, and the hypotenuse is 12. So that means opposite and hypotenuse will be sine. Sine 45 times 12, and it's pointing upwards, which means that it is positive. And for our remaining force, the 11 Newton force, acting 25 degrees below the horizontal, we need to deal with another right triangle, which would be that triangle there. So we need to work out its horizontal component, which again is the adjacent side, and we know the hypotenuse is 11, adjacent and the hypotenuse. That would be cosine of 25, and it's multiplied by 11, the size of the force. Horizontally, it's going to be positive, since it's pointing to the right. And for the vertical component, this is the opposite side of our triangle. We know the hypotenuse is 11, so opposite and hypotenuse is sine of 25. This will be 11 is the length of the force, and since it's pointing downwards, the vertical component is going to be negative. So we have to work out the totals. Negative 10 plus 12 times cosine 45 plus 11 cosine of 25 is 8.45. And in the vertical direction, we have 0 plus 12 sine 45 minus 11 sine 25 is 3.84. Both of those are positive. And that tells us that if we work out our rough direction, it's going to be, since the horizontal component is positive, that's going to be pointing to the right. And since the vertical component is positive, it's pointing upwards. So that's our rough direction. Let's draw in what we know. So we know that the horizontal component is 8.45 and the vertical component is 3.84. We're trying to find the magnitude, which means we need to use Pythagoras, which is going to be square root of 8.45 squared plus 3.84 squared, and if we calculate that we get 9.28 newtons. So we know the length of the resultant. Now we need to find the direction, which means we need to get that angle there. So theta equals, here we've got the opposite side, and this is the adjacent side. Opposite and adjacent is tan. We're finding the angle, so we need to take the inverse tan of the opposite is 3.84 divided by adjacent, which is 8.45, and if we calculate that, we get 24.4 degrees. So our resultant, which is the answer, is going to be, we've got a 24.4 degree angle, and the size was 9.28 newtons. Thanks for watching. Over and out.